Okay, this is your homework here. We did this, and you only have this left. So all of you can have different lines of best fit. I see that some of you, like right here, the y-intercept, um, here, don't choose this one. It's not on your line. Do not choose that one. So that's off. Don't choose that one. Choose the one that's on the line. So this is 22.5. So you can say that's 0 and 21. You estimate. You're estimating the line of best fit, okay? So y-intercept is 21. Okay, let's find the rate of change. So because we have the y-intercept, write a linear equation for the line of best fit for this graph. Y equals to mx plus b, because there's a b of 21. Okay, let's find the rate of change. Okay, the rate of change is, okay, that's 1 point. And if I choose another dot, I can choose 1, 2.5. That's 2.5. 7.5. Let's say I choose 5 and this number right there. So this is 17.5. Let's say 5 and 16. We estimate. You need to estimate where your point is. It doesn't have to be exact. We estimate. This is an estimation. So use round numbers. I see student using like 16.5. Don't do that. Just use 16. Okay? You're going to make your life harder. It's close enough. 5 and 16. So if you use 10, 10 and probably 11, because it's 12.5. So 10 and 11. Mine is 10 and 11. Yours can be different. Estimate. Doesn't have to be exact, okay? I'm going to check for this tomorrow. And if you do it wrong, I'm going to, B is 21. The rate of change, I'm going to use these two, x sub 1, y sub 1, x sub 2, y sub 2. So you know how to find the rate of change. You're rated 16 minus 21 over 5 minus 0. So this is negative 5 over 5, which is negative 1. So my rate of change happens to be negative 1x plus 21. Okay, write in linear equation that's parallel. Parallel means no solution. Y equals, so this rate of change has to be the same, and the y-intercept can be anything we want, plus 10. Explain why it's parallel. Parallel because that means it has no solution, because the rate of change, what we call slope, of negative 1 is the same, and the y-intercept of 10 and 21 are different. Okay? Now, same here. It's counting by the same number, so draw your line of best fit. There's no like exact one, because there's no y-intercept. We're not sure what this y-intercept is. We need to use point slope. Y minus y1 equals to m parentheses x minus x1. Okay, so I'm going to choose 5 and 3. Choose 5 and 3. This is 2.5. That's 3. I'm going to say 5 and 3. That's a good estimate of what that dot is. And then 10 and 7.5, 8, 9. Let's say 10 and 9. 10 and 8. Let's say 10 and 8. Always round. Don't use decimal numbers. You're going to be in a world of hurt. 15 and That's 12.5, so let's say 15 and 13. Whichever two you want to use. I'm going to use the two closest. I don't like to use the one that's far away. I'll just use the two closest. X sub 1, y sub 1, x sub 2, y sub 2. Okay? So, it just went out. Let me try it again and see what's going on with my reflector. Good thing I notice it. Instead of copying everything and not being done. Here we go. And then we find y minus 3 equals, we don't know mx minus 5. Okay, rate of change here. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, y sub 2 is 8 minus y sub 1, 3. X sub 2 is 10 minus the 5. 5 over 5, my rate of change is 1. Some of you, I noticed, had like 2.7 over 3. If that's the case, just divide this and round it to the nearest tenth, and that's your new rate of change, okay? You don't want decimals and numbers. But try to round your number up just like I did, and do not use decimals here. Just use whole number, estimated whole numbers, okay? I didn't have enough time to explain it. I see a lot of kids with problems. And this is y minus 3, add 3, add 3, y equals to 1x minus 2. And a negative 2, y-intercept, yeah, that looks like a negative 2 right there. So that's correct. I'm checking, notice I'm checking to see if it's right. My y-intercept is b is negative 2, my rate of change is 1. Make sure I do have this on the test, and kids miss this all the time. Okay, ruler, draw a line of best fit. Here's my line of best fit. Close enough. Okay. Oh, I have a y-intercept. Here's 2.5, so y-intercept is probably 0, 1. Use whole numbers, guys. So b is 1, so I can use y equals to mx plus b, and y equals plus 1, right? We need to find the rate of change. Get the next one. I say this is 5 and 9. 7.5. So I say this is 5 and 9. Close enough. This is 10. So 5 and 9 is right there. X sub 1, y sub 1. Okay, so we go x sub 2, y sub 2. This is x sub 1, y sub 1. 9 minus 1 over 5 minus 0. I got 8 over 5. So my rate of change is 8 over 5x. There we go. And it's positive. The line is going up. This line is going down. So I'm going to draw a line that goes in the middle. Okay, and I'm going to estimate. Again, this is 22.5, right? So this is probably 22, 0 and 22. My y-intercept is, hey, I have y-intercept. I'm going to use y equals to mx plus b, because my y-intercept is 22. Is that the same as that one? It sure looks a lot alike, huh? Oh, well, sure does. Let's do it again. It's the same as this one, you guys. I try to get in class, but anyways, do that, finish it. Here we also have a y-intercept. I'm going to draw a line that's in the middle of it all. Okay, so it's also 22.5, so I'd say this is 0 and 21. That's my y-intercept, so I'm going to use y equals mx plus b. B is 21. Okay, I'm going to use 5 and, okay, let me see, let me use 20. I don't like that one because we know it's 12.5. So I don't want to use the 12.5. I'm going to estimate my number. 15 and 14, right below it. I'm going to use 15 and maybe 14, right below it. Because it's not quite on this dot, guys. If you look at this, oops. Oh, anyways, this is the, oops. This is the other dot, and it's not on that line. So I'm going to estimate 15 and 14, okay? So x sub 1, y sub 1, x sub 2, y sub 2. All right, rate of change is 14 minus 21 over 15 minus 0. So this is 6, 7 over 15. So it's negative 7 over 15. Negative because the graph is going down. And that's my answer right here. Okay, because we have the y-intercept. That's, oh, that's right, you don't have this page. Gosh darn it.